The terms of an algebraic expression are separated by plus and minus signs. This expression has 6 terms. This is a term, 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 and this is a term. We can simplify this expression by combining all the terms that are the same. But when we look at them, our first instinct is that they're not the same. They're different. This is an x by itself. This is a 2 and a y, a 3 and an x, a 5, a 7 and a y, and a 2. We can see we could combine the 5 and the negative 2 and get a positive 3. So we know we can do that. But what about the others? Well, anytime we have variables that match exactly within a term, then we can add those together. And when we have a variable all by itself, we know we could put the number 1 in front of that variable to give it a value. So we have a 1x and a 3x that we can combine. Whenever we combine like terms, we always take the sign that is in front of that term to be the positive or negative sign of that term. So when there's not a negative sign, we assume it's a positive in front, because if it's negative, they'll put a negative sign in front of the problem. So we have a positive 1x and a positive 3x. So we know we can put that together and say 4x. That'll be a positive 4x. So we'll just write that like that in front of there. So now we have some y terms. So we have a positive 2y and a negative 7y. So we can subtract 2 from 7, and because 7 is a larger number, it'll be a negative sign. So we have a negative 5y remaining. And that's how we would simplify something like this. We look for the variables in the terms, and those are just the letters. That's the variable. And if the variables in the terms match exactly, then we can take what we call the coefficient, which is the whole number in front of the variable, and perform whatever calculation we need to with it. So that is how we combine like terms within an expression. So let's look at some more of this. I'm going to clear the page for us. So here we have an expression in example 94.1. We have a negative 3x plus 2y plus 2x plus 3 plus 7. So we're looking and we see we have some whole numbers here. Now when we have whole numbers in an expression where there are also terms with variables, we call the whole numbers constants. I'm not sure why they call them that. I guess because they don't have anything that can change them. So the value of those numbers are going to remain constant. I really think that's the reason. But we see we have a positive 3 and a positive 7. So we're going to combine those and make that a positive 10. So now I'm going to look for some more like terms. And I see a negative 3x and a positive 2x. Now we know when we have two numbers of different signs, and one of them is negative, we're going to subtract the smaller from the larger and use the sign of the larger. So in this case, 3 minus 2 is 1, and because the 3 is the bigger number, it's going to be a negative 1. So we're going to write negative, and that's going to be negative 1x. And then we have a 2y all by itself. It's a positive 2y. There are no like terms for it, so it just stays positive 2y. Correct? So now we're going to combine all of these into a single expression now that we have our answers together. And the only thing we're going to do different is drop the positive sign because we don't need that. This negative sign becomes the operation minus. And when we have a variable with the number 1 in front of it, we typically drop the 1 because it's understood that 1 times this is going to be whatever this is. So we just leave the variable by itself. And we're going to bring the positive 10 down, so it's going to be a plus 10. And that would be the answer to the combination of these terms into one expression. That's as simplified as we can get it. So let's clear this one and move on to 94.2. All right, in 94.2, we have a lot of expressions, or a lot of terms in this expression. So first I like to get rid of or not get rid of, but to combine the constants or the whole numbers. So here we have a positive 4 and a negative 2. When we put those together, we're going to get a positive 2. So let's put that here, positive 2. All right, and sometimes it helps to cross out what you've done so that you don't get lost in the process, especially when you have a lot of terms to deal with. So now we have, let's look at the letter x, variable x. We have a 3x, a negative 14x, and a positive 2x. I'm going to add the two positives together just because it's easy, and put that here, positive 5x. And then I'm going to subtract 5 from negative 14, and that's going to give me a negative 9x. So negative 9x, that uses all of these up. All right, so let's look at the m expressions, or the m terms in this expression. All the vocabulary, you would think there wasn't vocabulary in math, but there is. Positive 2, negative 4. We know that's going to be a negative 2m. So now we can combine this basically just like it is. Negative 2m minus 9x plus 2 is our simplified expression. And that's as far as we can go with that. All right, so that is how you combine like terms within an expression. You make sure that if there are any what we call constants, which are just whole numbers, we combine them. Then we look for terms that have identical variables. And it wasn't hard in this type of expression because each one only had one variable. But we will get to a point where they have more than one, and you're going to have to match them exactly. But for now, this is all we have for lesson 94. I'll see you in lesson 95.